basic details of air blast circuit breaker and state its types. So, in this type of circuit breaker, the blast of air is used to quench the arc. Arc is produced when the contacts are separated. At this time, the value of the compressed air opens and the blast of air goes into the arc. Arc is cooled due to the air blast and forces the arc products into the atmosphere. So, there is rapid increase in the dielectric strength of the medium between the contacts and the arc does not strike again. This type of circuit breakers are as follows. First is axial type or axial blast type circuit breaker. In this, the blast of air is in the direction of the arc, directly in the direction of the arc on the same axis. Cross blast type. In this, the direction of the blast of the air is perpendicular to the arc. So this is the arc strike between the contacts and the blast of the air is directly perpendicular, that is 90 degree to the arc. So this is how the air blast circuit breaker basically works, and these are two types of the air blast circuit breaker. State advantages of air blast circuit breaker. So there is no possibility of fire as the oil is not used in case of air blast circuit breaker. Arc products are forced out while in the oil circuit breaker. They remain in oil which contaminates it and replaced after some operations. So the arc products are within the breaker context and the wear and tear and carbonization forms, and due to which the maintenance is very high in case of oil circuit breaker, which is not the case in case of air blast circuit breaker. In oil circuit breaker, the energy required for quenching the arc is taken from the oil itself, while in this type of the circuit breaker, it is taken from the air. Arcing time is less, so the burning of the contact is reduced. Arc energy is less, so this type of circuit breaker is used where the frequent operations of breakers are necessary in case of LV circuit breakers. Size of the arc chamber is small. So these are some advantages of air blast circuit breaker. State disadvantages of air blast circuit breaker. So first is the capacity of air to quench the arc is relatively less as compared to the oil. There is effect of rate of rise of restriking voltage on the operation of this type of circuit breaker. Maintenance of the compressor plant also must be carried out in addition to maintenance of the circuit breaker. So these are some disadvantages of air blast circuit breaker. Explain construction of axial blast air circuit breaker. So the axial blast air circuit breaker is a type of air blast circuit breaker in which the airflow is directed along the axis of the arc to extinguish the air blast or the flow of the air in the direction of the arc to quench it effectively and efficiently. The breaker consists of 16 moving contacts. This the fixed contacts and the 15 moving contacts. Placed actually inside the insulating chamber like this. In made of copper or copper alloy for high conductivity and good arc resistance. A ceramic, metal, or a glass fiber reinforced epoxy resin nozzle is provided. Around the contacts for high thermal strength and insulation purposes. Now, the nozzle helps to direct high pressure air blast along the arc path, flowing, forcing it to elongate and cool the arc rapidly. Now, air reservoir is a steel tank where compressed air is stored at the high pressure, typically 20 to 30 bar. Air is not fully open. During the operation, the air is released through control valves to produce the axial air blast to quench the arc. The axial air blast is produced, so the control valve is right beyond this or the right beside this of the figure, which is not fully visible. Like the complex and nozzle are enclosed with an arc chamber. Both inside is the arc chamber. This is the arc chamber where arc occurs. So, and this arc chamber is made up of porous quenching takes place here in this arc chamber. Now, air valve and piping system made up of stainless steel or glass, which is corrosion resistant and suitable for high pressurized air, is part of this type of breaker. It controls the flow of compressed air to the arc chamber during the operation or the quenching mechanism. The operating mechanism made up of steel frame and mechanical linkages consist of pneumatic or spring operating mechanism or system that drives the moving contact and operates the air valve simultaneously. Means it is opening the air valve and operating the moving contact in the downward direction. So the airflow in the breaker increases rapidly so that the air can be quenched quickly. Epoxy resin or porcelain made insulating supports are provided, which ensure the insulation between the live parts and the grounded part of the structure, and it supports the assembly. Here we can visualize this. The series isolator is also provided here for the proper result. This we are going to explain between the working of the air blast circuit or the SGP, axial blast air circuit. So this is the construction of axial blast air circuit. Explain working of axial blast air circuit breaker. So during the normal operating condition, the fixed and moving contacts are in the closed position and allowing the current to flow through them. Now the air valve connected to the compressed air reservoir remains in the closed position, so no air blast is present in the arc chamber right now. Now when a fault occurs or breaker is operated manually or automatically, the operating mechanism, usually it is operated by pneumatic pressure or spring operation, initiates the opening of the moving contact away from the fixed contact. So the moving contact moves away or in the downward direction from the fixed contact, and simultaneously the air valve opens. So air valve opens and allowing the high pressurized air to enter in the arc chamber, and the moving contact is moving in the downward direction. Now as the contacts separate, the current continues to flow through the gap in the form of an electrical arc. This arc is established along the axis of the contact, hence it is called as the axial arc. The compressed air blast is directed axially along the arc path through the nozzle. The air performs three main functions, mainly cooling the arc column by carrying away the heat, elongating the arc to increase its resistance, and deionizing the arc path by sweeping away the ionized particles. Now, as the alternating current passes through its natural zero instance, the arc becomes weak and the air blast quickly deionizes the path between the contacts, preventing the restriking of the arc. The current is thus completely interrupted. Once the fault is cleared, the air valve closes and the contacts can be reclosed by the operating mechanism. The breaker is now ready for the next operation without replacing any quenching medium, unlike the oil circuit breakers. So this is the simplest working of the axial blast air circuit breaker. The series isolator is also operated because the distance between the main fixed contact and moving contact is very less. So to avoid the complete isolation between the contact, the series isolator is operated simultaneously and it is provided with the breaker. So this is the simplest working of axial blast air circuit breaker. State the advantages of axial blast air circuit breaker. So the axial air blast cools and deionizes the arc path very quickly, ensuring rapid interruption of the fault currents. Since air is used as the arc quenching medium instead of the oil, there is no risk of fire or explosion. Air is clean, non-toxic and non-polluting medium, making maintenance and handling easy. The same compressed air system can be used repeatedly for multiple operations without replacing the quenching medium. There is no carbonization or residue as in the oil circuit breakers available, resulting in low maintenance requirements. The breaker can perform frequent opening and closing operations without significant wear on the components. Pneumatic operation allows fast mechanical movement and easy remote or automatic control. The axial direction of airflow ensures uniform cooling and effective arc extinction at all the contact positions. Compared to the bulk coil circuit breakers, the axial blast design is more compact and lighter in the construction. So these are several advantages of axial blast air circuit breaker. Take the disadvantages of axial blast air circuit breaker. So the release of the high pressurized air during the operation produces the loud noise, which can be undesirable in substations. A separate air compressor, reservoir and a piping system is required or are required, increasing the overall cost and maintenance. The presence of the moisture in the compressed air can reduce the insulating strength and affect the reliable operation. Regular inspection and servicing of the air compressor and the control system. All the control valves are necessary to maintain the pressure and the performance. Leakage in the compressed air system can cause pressure drops, leading to delayed or faulty operation. For extremely high voltages, that is about 400 kV, the effectiveness of the air as a quenching medium decreases compared to the SF6 or vacuum circuit breakers. The pneumatic operating mechanism and air control valves make the system more complex than oil or SF6 type circuit breakers. The distance between the fixed contact and moving contact is less, that is required for the high voltage. So an isolator is kept in the series with the contacts. This isolator is opened immediately when the fault is cleared. So the required separation is obtained, and for this additional isolator structure is required, which increases the cost. The air reservoir must be recharged frequently to maintain the required operating pressure. So these are several disadvantages of axial blast air circuit breaker. Explain construction of cross blast air circuit breaker with a figure. So a cross blast air circuit breaker is a type of air blast circuit breaker in which the compressed air is directed across the arc path, that is the perpendicular to the axis of the arc flow. So arc is in this direction if suppose, then the flow or the pressurized air is flowing in the direction which is perpendicular or the right angle to the main arc axis to extinguish it. Now the breaker consists of fixed and moving contacts placed coaxially inside the insulating chamber. They made up of copper or copper alloy for high conductivity and good arc resistance. You can visualize this. These are fixed contacts. These two are fixed contacts and these are the moving contacts which are moving like this. So this plate you can visualize this. Fixed contact and moving contact. So when they are separating like this, then the arc is struck in between. The contact and nozzle are enclosed within the arc chamber made up of porcelain, bakelite or epoxy resin or insulating material which confines and quenches the arc or air blast. A ceramic or glass fiber reinforced plastic nozzle directs the compressed air across the arc path, that is right angles to the main arc, to blow out the ionized gases. It is heat resistant and insulating type material. Now air reservoir is a steel tank where compressed air is stored at a high pressure, typically about 20 to 30 bar. Air valve and piping system made up of stainless steel or a brass material which is corrosion resistant and suitable for high pressure air system. It controls the flow of the compressed air to the arc chamber during the operation. Now, operating mechanism made of steel frame and mechanical linkages consist of a pneumatic or spring operated mechanism system that drives the moving contact and operates the air valve simultaneously. The arc splitters are provided. These are the set of the baffle plates. These baffle plates are made up of metallic plates arranged close to each other in the region where the arc is confined or arc is struck in between. It is made up of steel or copper and are electrically insulated from each other. Baffle plates are important component used in the air circuit breaker to help in arc control, cooling and extension of the arc. These baffle plates are thin metal or insulating plates arranged in series inside the arc chamber. You can visualize this. This is the arc chamber and these baffle plates are arranged in the arc chamber. They are positioned such that the arc or hot gases strike or pass between them as it is driven by the air blast or magnetic force. You can visualize this. This air blast from the downward direction forces the arc towards flow towards the upward direction and they passes through the baffle plates. So the number of baffle plates and the arrangement depend on the breaker rating and the type of the breakers, whether it is air type or oil type. So this is the basic construction details of cross blast air circuit breaker. Explain working of cross blast air circuit breaker. So in normal operation, the fixed and moving contacts are closed, so that allows the current to flow through them during the normal operating condition. The air reservoir is charged with the high pressurized air, usually 20 to 30 bar pressure. But the air valve remains in closed position, so no air blast is present in the arc chamber at this time. Now when a fault occurs, the trip coil is energized, which operates the mechanism. The moving contact starts separating from the fixed contact and an electric arc strikes in between. As the contacts open, the current continues to flow through the ionized air path between them, forming an electrical arc. This arc is confined within the arc chamber and directed towards the nozzle and arc splitters. Simultaneously, the air valve opens, releasing the high pressurized air from the reservoir into the arc chamber. The air blast is directed transversely, that is, the 90 degree to the arc path or at the right angles to the arc. The air performs three main functions, mainly blows the arc into the arc splitters, diverting it into the smaller arcs, cools the arc rapidly by removing the hot ionized gases and deionizing the arc path by sweeping away the ionized particles. Now, as the alternating current approaches its natural zero, the arc becomes weak. The cooling and deionizing effect of the cross blast prevents the arc from restriking. Thus, the current flow stops completely and the arc is extinguished. Once the fault is cleared, the air valve closes and the contacts can be reclosed manually or automatically. The breaker is ready for the next operation without replacing any quenching medium, as only compressed air is used for the arc extinguishing. So this is the simplest type of working of cross blast air circuit breaker. State the advantages of cross blast air circuit breaker. So, the air blast directed across the arc cools, elongates and deionizing the arc, resulting in fast arc extinction. As the air is used as the arc quenching medium instead of the oil, there is no risk of fire or explosion. Air is clean, non-toxic and readily available, making the breaker environmentally safe and easy to maintain. The compressed air can be used repeatedly for multiple operations without its replacement, reducing the operational cost. There is no carbonization or decontamination unlike oil circuit breakers, leading to lower maintenance requirements. The pneumatic mechanism allows quick contact movement and fast fault clearing, improving the system reliability. Cross air blast effectively blows the arc away from the contacts, resulting in less wear and tear and longer the contact life. Ideal for system where frequent opening and closing operations are required, that is, for testing or switching substations. Cross blast design allows for a smaller and lighter construction compared to oil circuit breakers of the same weight. After the arc extinction, the ionized gases are quickly removed, restoring the high insulation strength between the contacts. So these are several advantages of cross blast air blast circuit breakers. The disadvantages of cross blast air circuit breaker. So it needs a high pressure air supply system for the arc extinction purposes, which increases the operational cost and maintenance. The release of compressed air during the operation produces a significant amount of noise. Continuous maintenance of the air compressor and associated pipes is necessary to ensure the reliable operation. The mechanical movement of the valves and the use of compressed air make its operational slower. Leakage in the compressed air system can lead to malfunction or failure of the breaker. Due to the air system components, the overall setup is larger and less compact than the modern SF6 or vacuum circuit. So these are several disadvantages of cross-blast air blast circuit breaker. Explain construction of SF6 circuit breaker with figure. So in this type of circuit breaker, sulfur hexafluoride gas is used as the quenching medium instead of oil or air. The enclosure, that is tank or the chamber, this enclosure, tank or chamber, holds the entire interrupting unit and maintains SF6 gas under the pressure. It is made up of stainless steel or aluminum alloy for the strength, gas type sealing and corrosion resistance, or partially in older outdoor type SF6 circuit breakers for insulation and mechanical support purpose. Gas chamber or interrupting chamber unit is the main part of the breaker where arc interruption takes place. You can visualize this. This is the arc chamber here. It is filled with SF6 gas at a pressure of about 3 to 5 kg per centimeter square. Stainless steel chamber lined with epoxy or composite insulation internally to ensure the dielectric strength of the proper assembly. Now it contains the fixed contact and moving contact made up of copper tungsten alloy for excellent electrical conductivity and high melting point for the arc resistance. Contacts with silver plated surfaces are used to reduce the contact resistance and prevent oxidation. They carry the load current under normal condition and separate during the fault condition. So this is the moving contact and the rest is the fixed contact. Here you can see this. This is the fixed contact and this is the moving contact which moves in the downward direction like this. Now arc quenching nozzle of PTFE, that is polytetrafluoroethylene or Teflon material, provides high thermal resistance, low dielectric loss and good insulation properties. It directs a jet of SF6 gas to the arc zone during the contact separation for cooling and deionizing purposes. Operating mechanism is made up of steel framework for strength and rigidity. Spring, hydraulic or pneumatic mechanism typically uses high tensile alloy steel for moving parts and insulated linkages, that is made up of epoxy or fiberglass to transmit the motion safely. It provides mechanical energy to open or close the contact during the operation. Now the SF6 gas system includes a gas reservoir, compressor, pressure gauge, relief valves and gas leakage detectors. It maintains required gas pressure and purity for insulation and arc extinction purposes. Insulators and supports electrically isolate live parts from the grounded components and provide mechanical support. Epoxy resin or ceramic, that is porcelain, provides high dielectric strength and mechanical rigidity. Control circuit housing contains trip coils, control relays and auxiliary contacts. Mild steel or aluminum enclosure is used with internal plastic or epoxy insulation for the control components. So this is the complete structural or constructional details of SF6 circuit breaker with the material used for each part with the figure. This is the simple figure. You can see this. This is the inlet of SF6 gas valve. This is the gas outlet. This is the moving contact and here it is fixed contact. Arcing horns are also provided as a part of the protection purposes for the breaker. In the breaker at very high voltages it is used. We can see the working of arcing horns during the working of SF6 breaker. So it is not included in this video. This is the arc chamber or the complete enclosure or the tank. This is the insulating support or rod to operate moving the member or the moving contact. So this is how the SF6 type breaker is look like constructionally. simple figure you have to draw when asked in the examination. So this is the constructional detail of SF6 circuit breaker with the material required for the construction. Explain working of SF6 circuit breaker. So the SF6 gas circuit breaker is sulfur hexafluoride circuit breaker. This gas is of electronegative type which absorbs the electron rapidly. So when the arc is produced, blast of the gas is directed on the arc. Electrons are absorbed by this gas and immobile negative ions are produced. So there is rapid rise in dielectric strength of the medium and arc gets quenched. Now during the healthy condition, the fixed and moving contacts are in closed position like this, allowing the current to flow through the breaker. Now the SF6 gas inside the chamber acts as an insulating medium, preventing any leakage current between the live parts. When a fault occurs in the system, trip coil of the circuit breaker is energized by the protective relay. The operating mechanism, either spring operated, pneumatic operated or hydraulic operated, drives the moving contact apart from the fixed contact, that is the contacts are separated. As the contact starts to separate, an arc is struck in between them because the current continues to flow through the ionized air around the contact surfaces or the gas. During the contact separation, the arc energy causes the surrounding SF6 gas to heat up and expand. The design of the arc chamber and nozzle directs a high pressure jet of SF6 gas through the arc region. The gas flows from high pressure to low pressure side, sweeping away the ionized particles. Valve of the SF6 tank opens and the gas enters the chamber with the pressure of 14 kg per centimeter square. Arc gets cooled due to the high pressure blow of SF6 and absorb the electrons in the arc, and immobile negative ions are produced. SF6 gas has strong electronegativity, meaning it readily absorbs the free electrons from the arc plasma. This forms heavy negative ions, that is SF6 minus, which reduce the number of free electrons needed to maintain the conduction. The arc cools rapidly, loses conductivity, and is extinguished as the current passes through the zero. Now, after the current zero, the SF6 gas quickly deionizes the arc path, restoring the dielectric strength between the contacts. The gas pressure system restores equilibrium by redistributing the gas between the chambers. The contacts remain open, isolating the faulty section from the healthy one or from the rest of the system. The breaker can be reclosed once the fault is cleared and the gas pressure is maintained or normalized. Valve is closed by the spring or exhausted, and as exhausted SF6 gas is collected in a tank and it is taken in use after the reconditioning. State advantages of SF6 circuit breaker. The quality of the arc quenching is good, so the arcing time is less. The dielectric strength of SF6 gas is 2 to 3 times that of the air, so it can be used to break the higher value of the currents. Noiseless operation and exhaust gas does not go into the atmosphere. There is no danger of catching fire as it is not inflammable. Gas enclosure is closed, so moisture does not enter into it. Carbon particles are not produced, hence no problem of insulation and carbonization. It is totally enclosed type and it is isolated from the atmosphere. So these are useful in the places where explosions take place. And the biggest advantage is maintenance is relatively less. So these are some advantages of SF6 type circuit breaker. State disadvantages of SF6 circuit breaker. SF6 circuit breakers are more expensive than coil or air circuit breakers due to the cost of the gas and gas handling equipment. Small gas leaks can occur over the time through joints and seals that causes the loss of SF6 gas reduction, dielectric strength, and requires periodic refilling. The SF6 is a greenhouse gas with a global warming potential about 23,500 times higher than the carbon dioxide. So special care must be taken to prevent its release into the atmosphere. SF6 requires special gas handling equipment, that is vacuum pumps, gas reclaimers, detectors, and trained personnel for the maintenance purposes. Now, when the SF6 gas is exposed to high temperature arcing, it can decompose and form toxic or corrosive gases like SF4, SOF2, SO2F2. These byproducts are harmful and require proper filtration and protective gear during the maintenance. To maintain the gas pressure and insulation, the enclosure must be completely leak-proof, which increases the manufacturing complexity. SF6 gas and refilling equipment are not easily available anywhere. So, especially in rural or remote area installation, it is very difficult to refill it again. So, these are several disadvantages of SF6 type circuit breakers. Applications of SF6 circuit breaker. So, it is widely used in transmission and distribution networks from 33 kV to 800 kV due to its excellent arc quenching and high dielectric strength, ensuring safe and reliable operation under high voltages. It is used as interrupters in SF6 gas insulated substation where compactness and reliability are essential for urban or indoor substation in areas with dense population. It is installed in generator circuits and auxiliary switchgear to protect alternators, transformers, and feeders from the fault currents. It is used in large industrial plants, that is steel mills, refineries, manufacturing units requiring high reliability and compact switchgear. It is ideal for underground substations and shipboard power systems where compact, sealed, and low maintenance equipment is needed. It is used in the solar farms and wind power substations to protect and isolate high voltage connections to the grid. It is very suitable for frequent switching operations of capacitor banks and reactors due to the low wear on the contacts and excellent arc interruption or suppression properties. So these are the applications of SF6 circuit breakers where they are utilized or installed. Properties of SF6 gas. So it is colorless, odorless, that is smell, and non-flammable gas. It does not react with the metals or insulating materials, ensuring long equipment life. Thermally and chemically stable up to about 500 degrees Celsius temperature. It is about 5 times heavier than air, that is 6.14 kg per meter cube at 1 atmospheric and 20 degrees centigrade, that is 1 atm pressure. It has 2.5 to 3 times higher dielectric strength than air, making it an excellent insulating medium. It has high thermal conductivity that helps in cooling the arc efficiently. At high temperatures during arcing, SF6 decomposes to form toxic and corrosive gases like SF4, SOF2, SO2F2, which are later neutralized by the filters. Excellent arc quenching ability due to strong electronegativity, means absorbing the free electrons. SF6 molecules attract free electrons, forming negative ions that reduce current conduction. It liquefies at high pressure or low temperature. So these are several properties of SF6. Explain working principle of vacuum circuit breaker. So a vacuum circuit breaker, that is VCB, works on the principle of arc extension in vacuum. So when the contacts are separated in vacuum, that is at the 10⁻⁻⁷ to 10⁻⁵ torr pressure, arc is produced due to the ionization of the metal vapor of the contacts due to the high field emission. These metallic vapor ions and electrons are condensed on the surface of the contacts. This arc is quickly extinguished because there are no gas molecules to sustain the ionization. The dielectric strength of the vacuum is very high and rapidly restores insulation after the current interruption. Thus, there is rapid rise in the dielectric strength and arc is thus quenched. So this is the basic working principle of vacuum circuit breaker, in which the arc is extinguished in the medium, that is in the vacuum. Explain construction of vacuum circuit breaker with a proper figure. So, vacuum interrupter, that is arc chamber, is the heart of VCB. It extinguishes the arc when contacts separate in vacuum, that is at the pressure of 10 raised to minus 6 torr, in the range of 10 raised to minus 5 to 10 raised to minus 7 torr. Ceramic or glass material is used to maintain the vacuum and provide insulation in between. Fixed contact and moving contact and arc shield are kept in one vacuum chamber. Copper or chromium alloy, that is the mixture of these two, or tungsten copper is used for the contact material. Bellows are made of stainless steel. The bellows are made of stainless steel that allow the movable contact to move while keeping the vacuum seal intact. That is, movable member is joined to the control mechanism through this stainless steel bellow. This is the bellow and this is the moving contact. You can visualize this. This is the moving contact and this contact is a fixed contact which is fixed with the frame. Here you can visualize this. Now, the operating mechanism provides mechanical energy to open and close the contacts. It is operated manually, electrically or via spring charge mechanism and ensures rapid contact separation, that is from fixed contact to moving contact separation like this. Insulating housing, that is enclosure, is made up of epoxy resin or porcelain material. It provides external insulation between phases and to the ground. Current carrying terminals made of copper or aluminum are connected to the fixed contact inside the interrupter and external circuit outside. Arc shield, that is metal shield, is a cylindrical stainless steel shield placed inside the vacuum interrupter. It prevents metal vapors from depositing on the inner surface of the insulating envelope. Means shield prevents condensation of this vapor on the inside wall of the exterior body, so there is no decrease in the dielectric strength. Metallic vapor is produced due to the arc when the contacts are separated. So this is the complete figure. You can visualize this. This is metallical bellow. These are the end flanges. Here you can see this. These are the end flanges. This is the connection in between. This is the outer glass enclosure. Here you can see this. This is the airtight seal or the vacuum seal intact, and this is the sputter shield, that is the arc shield or metallic shield that is provided on the either side of the contacts. So this is the moving contact and this one is the fixed contact. So this is the basic constructional detail of vacuum circuit breaker with a proper figure. Explain working of vacuum circuit breaker. So a vacuum circuit breaker, that is VCB, interrupts the current by separating its contacts in vacuum. The vacuum acts as the arc quenching medium since it has the highest insulating strength and contains no gas molecules to sustain an arc. In normal healthy condition, both the contacts are closed, allowing the current to flow through the breaker. The fixed contact and moving contact are in touch inside the vacuum interrupter. The current passes with negligible contact resistance. Now when a fault, that is a short circuit or overload fault, occurs, the protective relay sends a trip signal to the operating mechanism of the vacuum circuit breaker. The operating mechanism, either spring operated or magnetic actuator, moves the operating rod to separate the contacts. So the moving member is isolated from the fixed member now by the tripping mechanism. Now as the contacts start separating, the metallic vapors and electrons emitted from the contacts from a plasma and a vacuum arc is established in between them. The arc current continues to flow through the plasma column, that is in between the value of the fixed contact and moving contact. A space of without air or the separation space or the gap available is termed as plasma contact. Now the contact material, usually copper, chromium alloy, produces fewer metal vapors and the arc remains contracted and short-lived. Now when the current passes through the natural zero in AC systems, the number of charged particles drops because there are no gas molecules in the vacuum to ionize the arc again, the arc cannot restrike. The metal vapors condense quickly on the arc shield and contacts, restoring the vacuum's dielectric strength up to the thousands of volts in microseconds. Less separation of contacts is required as the dielectric strength of the vacuum is very high. Thus, the arc extinguishes completely at the first current zero interruption. After the arc extinction, the vacuum gap between the contacts immediately regains its full dielectric strength. No reignition occurs even if the voltage recovers rapidly across the contacts. The fault current is interrupted successfully. So this is how the vacuum circuit breaker works to interrupt the fault current. Write 4 advantages of vacuum circuit breaker. So first is, there is a little possibility of fire as the vacuum is the absence of air. So the possibility of fire is very less. Gases are not generated during this operation. The breaker is very simple and reliable and robust in construction. So the life is very long. Maintenance required for this type of breaker is very less. The operation is noiseless, means quiet operation. The inertia is less, so the driving power required for this force breaker to open is very less. Energy of the arc produced is very less. It can withstand the lightning surges as well. So it can use for the higher value of voltages. It can break large value of fault current, and the fault can be cleared before the moving contact reaches to its final position. Disadvantages of vacuum circuit breaker. For voltages above 33 kV, the cost of the multiple vacuum interrupters per phase and the insulation becomes very high compared to SF6 or air blast circuit breakers. The short circuit current interrupting capability of VCBs is limited. They are not suitable for very high fault current levels. If the vacuum seal leaks or the vacuum leakage waves, the entire interrupter unit must be replaced as it cannot be repaired or refilled again. Now, loss of vacuum due to the seal failure can cause loss of insulating strength, making the breaker unsafe to operate. It requires vacuum monitoring or periodic testing. Now, when the interrupting small inductive or capacitive currents, VCBs may produce high transient overvoltage due to fast current interruption and high dielectric strength or recovery rate. Though maintenance is low, the initial manufacturing cost of a VCB is higher than that of oil or air circuit breakers of the same rating. Vacuum interrupters are fragile and must be handled carefully to avoid mechanical damage to the ceramic envelope. So these are several disadvantages of vacuum circuit breaker. Applications of vacuum circuit breaker. Most commonly used in medium voltage switchgear for distribution networks, that is for 3.3 kV to 33 kV. It is suitable for both indoor and outdoor type installations. It is installed in industrial plants, steel mills, cement factories, and chemical industries for protecting motors, transformers, and feeders from faults. Now, it is installed in 33 by 11 kV or 11 by 0.433 kV substation for feeder protection and sectionalizing in rural and urban distribution substations. Breakers are used for switching and protecting generators, power transformers, and bus bars in the medium voltage substations or systems. The VCBs are ideal for frequent operations such as capacitor bank switching and large motor control due to its long mechanical operating life and arc-free operation. VCBs are used in electric traction substation for reliable interruption and minimal maintenance. These VCBs are compact, sealed design, and absence of oil or gas make it safe in mines and underground installations. Breakers are employed in solar farms and wind power plants at medium voltage collector stations for feeder and transformer protection. So these are some applications of VCB.